Let's talk about electrical panels, all the different parts and how they work. So if you are an apprentice and you haven't yet worked on one of these, or if you're just starting to work on them and you're kind of a little unsure about all the parts and pieces and what it all does, this video is for you. So let's start out with a little bit of terminology first, because just at its bare bones, you need to know the words that code talks about when you're talking about panels, but you also need to know like what you're talking about when you're talking about them. So a lot of people will say like, go to the panel and trip a breaker. But this entire thing, the marketing on a package when you go to buy one, oftentimes it says load center. So a load center is something that has a panel board inside of a cutout box or an enclosure. Some people will call these fuse boxes. That's incorrect. There's no fuses in here. This is a box of breakers. It is an electrical panel. In code, you're going to see cutout box and cabinet talked about a lot. A cutout box is specifically something that is flush mounted, meaning that it is recessed inside of a wall. Typically, it's got a bunch of little knockouts and stuff, and then it has a panel board inside of it. When you're talking about a cabinet, you're talking about an enclosure that's usually meant to be surface mounted. And a lot of times they don't have all these knockouts and stuff. They're just kind of like a clean, smooth enclosure that you surface mount, and they will still have a panel board in it. Now, the panel board, the actual guts, what we call them, the guts out in the field, that's all of this stuff. A lot of people don't realize this, but you can take the entire panel board out of an enclosure. So say you mess something up or something like melts inside of here and you're like, crap, I got to get a whole brand new panel. You actually don't have to. You can get a panel board, or if you've just got a few of these laying around the shop, you can pull the panel board out if it's a pain in the butt to replace the whole thing. And with a few different screws, pull this out, put the new one in. So this is the panel board. Inside of a panel board, we've got bus bars. So this bus bar goes all the way up to one side of this breaker, and this bus bar goes to the other side of the breaker. So we would say this is like your A phase and this is your B phase. Everything that's connected on this side, you can see every other breaker has some sort of little blades coming off of it, little fingers. So every other breaker is going to be on this bus bar, and then the other bus bar is going to fill in the gaps on the other side. Some other parts that we need to know are that we have these extra buses. This is considered a neutral bus bar. And we have these little ground bus bars. Now, if you notice, the neutrals all have plastic behind them, and it's to keep the neutrals isolated so that they're not connected to the panel. Neutrals can have current on them, so since they are considered a current carrying conductor, most of the time, we don't want current flowing on any energized metal parts. So we want to isolate all of our neutrals. The one instance where that's not true is out at the service panel. When we have an electrical service, we're always trying to bring all of our grounding electrode conductors and all of our neutrals together at a single point so that bonds them all together and it keeps them all at the same potential. And in that case, you're going to see these little green screws right here. These green screws are main bonding jumpers, or they're bonding screws. You want to, in 98% of the panels that you're going to install out in the world, you take these things and don't let them go in the panel. But if you have a service panel specifically, if this was an outdoor panel and we were building this as our service panel, then we would put that ground screw in there. That's very, very important. So we have the neutral bus bars. All of our neutrals, our whites, end up landing on the neutral bus bars. We have ground bus bars that actually mount right to the panels themselves. I like to put mine down at the bottom. Some people put them up here. There's a lot of stuff going on the sides over here. So I just try to keep them all completely separate. It's just cleaner and easier to access. But you do have a ground bus bar and neutral bus bars. Now with this panel, you'll notice that there's this extra bar going down on the inside, but with this one, there's not like an extra bar that the breaker's attached to. So if I were to pull, let's say this one off of here, you'll notice there's a piece of metal right here, and this metal is actually the neutral. So this specific type of breaker takes a hot and a neutral into it, and normally we would have to connect that neutral to the neutral bus by one of these pigtails. But now that these plug-on neutral style panels are out in the world, we have special breakers that are plug-on neutral breakers. And so you don't have to even run wires. It's just inherent in the design of the breaker. They stab into those neutrals. So this is a plug-on neutral style. This is not. Now let's talk about quality products for a second. You're going to notice in doing service calls over the years that there are some brands out there that don't have the greatest dual function technology, or that their arc fault technology constantly nuisance trips where you're having to replace breakers all the time. So you want to ensure that you have a really good product that's been time tested. So this might look a little familiar to some of y'all. It essentially looks like a GE panel, right? But it's not GE, it's ABB. And the reason is ABB bought out GE's residential breakers. So now we have a product that all of us have loved and trusted for years. It's just under a different name. So this panel specifically is an ABB ReliaHome P Series Plus panel. It's plug-on neutral. It's got all the same functionality that you would expect because ABB as a company generally sticks with quality products. So a lot of us use Carlon boxes, right? Like they're blue boxes in residential that we use to wire homes. Carlon is owned by ABB. Steel City, the metal boxes that we use in commercial, they are owned by ABB. So if you want to get a quality product, I would recommend using these ABB panels. And at a certain point, you're not really going to have a choice, because if you have a GE product, you're not going to be able to find those GE SKUs anymore. And ABB has replacements for a lot of things. Like recently I was at a commercial job and it had a GE Spectra molded case main distribution panel. And I couldn't find that GE Spectra breaker anymore. ABB has a replacement series of breakers just for that. So worry not if you can't find your favorite GE stuff. They're going to be even better ABB stuff. Now, these types of panels can be different from panel to panel. You'll have what's called an MBR panel or an MLO panel. MBR means main breaker, and MLO means main lug only. So this is something that has a breaker in it, right? I bought it this way. It has a breaker in it. It's considered an MBR panel. But you can get some that you don't have to have a breaker in. You just have lugs. So when you bring your feeders in, you land them on lugs, and there is no breaker that you can just de-energize the entire panel with. But with MLO panels, oftentimes you can buy breaker kits. And if you just installed one, you're like, oh crap, I actually do need a main breaker in this panel. Not to worry, a lot of times you can get that and you just pull these little nuts out, stick the breaker kit in and screw them back in, and boom, now you have a main breaker that can de-energize everything. The main breaker kits typically come with their own lugs. So instead of you screwing into the lugs of the load center, you're putting your conductors into the lugs on the breaker. And that's how it feeds everything through. Another thing to notice is that both of these panels are used in completely different environments. So this is a single phase panel, just means that you got two hots inside of here. You got two bus bars. So typically when you're working in residences, you're gonna be dealing with single phase power. And in this one, you'll notice there's three bus bars. There's one on the left, one in the middle, and one on the side. This is for three-phase environments. And when you're in commercial or industrial, you're gonna be dealing with three-phase. You might see some weird, like older, down in Austin here, we've got a few neighborhoods that still have some three-phase stuff, so you'll see three-phase in houses, but it's more rare. Now, the really important thing to understand about these bus bars that I mentioned are that the bus bars are what drive the rating of the size of the panel. So this is a 200 amp panel and this is a 200 amp panel. Has nothing to do with the breaker, because a minute ago I said an MLO panel doesn't have a breaker, right? So it has nothing to do with the breaker size. It has to do with the bus size. So this bus bar on this side is capable of maintaining constant current of 200 amps through it. It's not going to fry, nothing's going to happen. It's rated and listed at 200 amps. There's also a bus bar here that can handle 200 amps. That does not mean that you have a 400 amp panel or that you can run 400 amps through this. It's just saying through each one of the phases, each one of the big conductors that we land in here, we have 200 amps that we can run through it. And since this is all just one big loop anyways, it's a loop from the black to the red, it's just the same 200 amps through the entire thing. So the bus bar is what gives a panel its rating. Also for ratings, you're gonna see indoor panels and outdoor panels. You gotta be very specific. Any kind of an outdoor panel is probably gonna carry a label on it that says NEMA 3, and any indoor is probably gonna have a NEMA 1. The NEMA numbers can kind of be all over the place. There might be some different environments that things are rated for that are more specific, but in general, indoors your NEMA 1, outdoors your NEMA 3. Another thing to note is that not every 200 amp panel is going to be the same size. This is a 30 space panel, which means you can go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 spaces per side, which means there's 30 total spaces. So this is a 30 space 200 amp interior panel. Now, outside of just the spaces, there's a certain amount of circuits you can put in these as well. You can get breakers that are a single pole like this, but that have the ability to take 2 circuits in. And a lot of times they'll have 2 different handles on them. You might have one up here, one down here, but you can put 2 circuits per space. So a 30 space panel may have 60 circuits that you're able to put into it. And as long as we're talking about ratings, it's worth noting that most modern electrical panels, you can mount them upside down. We can do what's called bottom feeding. So you feed your incoming feeder into the bottom of this panel. Top fed is how we normally align them, and you just feed it through the top. But you do have to be careful because not every panel is going to be rated to be able to be bottom fed. And there's a rule in code that says that if there's a breaker that's in a vertical position, the on has to be the up position. So like in here, it doesn't matter because we have a side to side, right? It says on here and off is on this side. So no matter which way I orient this, I'm not gonna have a problem. But if you do get a panel that has a breaker that is up and down and on is on the top and you flip it around, you are violating code. So just be careful when you're trying to bottom feed. Make sure that the panel that you have is listed to be bottom fed. And again, most of them these days are. Now, since we're talking about breakers, let's look at a whole bunch of different breakers. So we have what's called a single pole breaker. Most often you're just going to be installing something like this. It says 20 on it. There's one handle, one hot goes in it. That's it. It's a single pole breaker. You also have 2-pole breakers, and this is a 2-pole breaker, 2 handles. This one is a 2-pole 30. It says 30 amps on it. This one says 20. There's also 2-pole 20s. I've got a 2-pole 20 right here. So yeah, that's a better example. We take a 2-pole 20 and a single pole 20, they look like the exact same things, right? Like we could just extend this handle out here if we needed to, but they are. It allows 20 amps total to flow through the breaker. So just because you see 20 amps and 20 amps, that doesn't mean this is a 40 amps of current that's flowing through it. It's 20 total amps. So that means that since we have a black and a red, we have a total of 240 volts. It means current's going through this way in equal but opposite magnitude that it's going in this way. So 20 amps is flowing at all time through the entire breaker. It's just taking 2 paths, or it's taking 2 sides of one loop to make that happen. So don't ever think that there's 40 amps flowing through a 20 amp breaker. That seems to be a trend on TikTok where people are arguing that. They're wrong. It is 20 total amps. So single pole breaker, 2-pole breaker. And then when we get into the 3-phase environments over here, we have a 3-pole 20. So again, same thing. We have 3 hots that get fed into this. Still just 20 amps here, 20 amps here, 20 amps here, but it's the same 20 amps. So just which path it's taking through which breaker, but a total of 20 amps because we run 20 amp wire out of it. It can't be 60 amps flowing through this on 20 amp wire, right? Also, when you're putting breakers in, most of these panels, you'll notice that there's like these kind of little fingers on the outside and they match up with the back sides of these. So anytime you put a breaker in, you first want to come to the back side and hook it in place and then push it to get it to push onto these blades. Now, breakers come in all kinds of sizes, but there are definitely set sizes. You're not going to find like a 3 amp breaker or 7 amp breaker or something like that. You're going to have them in multiples of either 5 or 10. So we start out, kind of the lowest thing we are going to see out in the field as electricians are 15 amp, 20 amp, 30 amp, 40 amp, 50 amp. You're going to see some like 25s and 45s and stuff like that. And most of these miniature circuit breakers, you're dealing with like up to 60 amps in a house. You might have some 70s, 80s, 100s, depends on what kind of house you're building and how much pool equipment and crazy stuff that it has. But most of the time, if you have to go up to like 150 amp load or something like that, they're not going to be able to have a small circuit breaker like this that's that size. Now, you'll notice there's a couple other styles of breakers. So these ones have some colors on them, and it's because these are ground fault breakers, these are arc fault breakers, and these are dual function breakers, meaning it has both ground fault and arc fault combined into one breaker. If you have ground faults, if you're working, if somebody's like standing on concrete and there's water everywhere and they go to plug something in and their finger touches, current could go through their body. So this breaker actually monitors hot and neutral to make sure that there's no imbalance. And if it detects any kind of slight imbalance where current might be going somewhere else, it immediately shuts the breaker off. So you're probably used to seeing like GFCI receptacles. You don't have to put the receptacles. You can actually put breakers. They're a little bit heavier duty. They got a little bit smarter technology to them. There's a lot less nuisance tripping. Again, depends on the brand, but I typically go with these breaker style devices rather than the point of use devices. And plus, you don't want to put a like GFCI receptacle like behind a refrigerator or under a counter that somebody's got to dig under there and reset it. Don't be that guy or girl. Just put them in the panel. Arc fault breakers, same thing. They make arc fault receptacles. There's different code reasons why you might want to use one or a combination of both of them. But arc fault breakers detect series arcs where you're like, you know, two things are arcing together, or they do parallel arcs where you might have a hot and a neutral arcing against each other, or like a neutral and ground, or two hots or something like that. So anytime you put any of these breakers in, you always want to, when you energize the panel, make sure that they trip, you know, like turn them on, turn them off, make sure you hit the GFCI test, or the parallel arc, or the series arc. Or if you have a dual function, since it has both ground fault and arc fault in it, just make sure that you do a ground fault test and arc fault test. I mentioned that there are two different styles. There's the plug-on neutral style, and then there's the pigtail style. Doesn't matter what you use, you can cut these. That is 100% fact from the manufacturer of every one of these breakers. There's no harm in cutting these. I typically, if you have like 15 of these in a panel and they're on both sides, you're gonna have all this squiggly, crazy crap. So I like to try to like straighten mine out, you know, and pull them out as long as I can, and then I'll cut them. The only downside in cutting them is that you can't really move it once you've cut it, right? You're gonna be out of neutral. So just make sure you think about the benefits of whether or not you're going to cut these, or if you're even going to use them, if you're just going to stick with the plug-on neutral style. I think the plug-on neutral style saves you can do the same amount of work in about 1/10 of the time. And you don't have to fish conductors down if you need to add one later or take one out or move it. The pigtails are just annoying. Every brand has them. Some people just like them, others don't. Now, one really important thing about breakers is that breakers do not put out electric current. You don't have a 20 amp breaker that's like sending 20 amps out when you turn this on. We can't control the amount of current that flows through circuits. The load that we're energizing, we bring those wires over to a load and connect them across that toaster, that motor, whatever it is, the inherent resistance inside that thing is going to start drawing a certain amount of current through the circuit. So we might have like a 10 amp load that's plugged into a receptacle. So in this 20 amp breaker, only 10 amps are going to be flowing through it. But if there's a problem with that thing and something happens and now it starts drawing more current, or we plug too many things in, we might start drawing like 23 amps through it. And it's like, oh crap, that's a problem. So the breaker needs to be able to trip, and it can trip on its own. That's what these breakers do. There's two elements inside of here. There's a thermal trip mechanism and a magnetic trip mechanism. Thermal trips are for overloads, and an overload just means that the circuit is overloaded. There's too much on it. There's too much current flowing through. But it can be a small amount above whatever that breaker's rating is. So this is a 20 amp breaker. For the thermal overload to kick in, it has to get to a current of about 120 to 130% of that 20. So 20 times, 1.2, we're probably talking like 22 amps or something like that. But if you'll probably see this if you're ever in an environment where you put a clamp on ammeter on, you're like, holy crap, there's like 23 amps running through that 20 amp breaker. Why is it not tripping? It just hasn't gotten to the heat threshold where it needs to trip. So the thermal trip mechanism has this bimetallic strip on the inside, and as heat builds up, it starts to separate, and these are just spring-held devices on the inside. So when it gets to a certain point, that spring no longer holds and it opens the circuit up. That's one condition. Every breaker works off of that. The second condition is a magnetic trip mechanism. And so a magnetic trip mechanism has to save on short circuits or ground faults. Those are huge impacts. That's like two hots touching each other, hot neutral, something like that, hot to ground. So that's a massive amount of current. So anything over 200% of that breaker's rating, it needs to trip at up to a certain threshold. But those are two different reasons that we use breakers. They're two different problems that it can happen in a circuit. And all of these breakers do that. It's just that these extra breakers over here also have a third function. So this one will still operate thermally and magnetically, but it also operates if there's a fault condition, specifically a ground fault. These will do two different arc fault conditions. So this one has kind of four functions really, and the two thermal and magnetic trip. And then this dual function, obviously GFCIs and arc faults and the two other normal conditions. Now, to finish this off, I wanted to give you guys a few different tips for when you're working with electrical panels. The first thing I would always, this is my preference. There's nothing that says you have to do this in code, but my preference is always to align all of the tops of your panels. That way, all of the wires that come in, you know what the lengths are and you can kind of cut things before you start ripping out and making up the panel. But I think it also just looks way cleaner. Some people like to align the bottoms of them, and then you got the heights, all these different heights, but it's harder to gauge wire length when you're doing something like that. So that's just my personal preference. Whatever you do, make it look really neat and clean. You are professionals. You're not some hack from Craigslist or some husband that's bored on the weekend doing this. You are a professional electrician, so everything you do needs to be neat, level, and clean. Speaking about the top, the heights of these things, there's a rule in code that you can't put the highest handle in a breaker any more than 6'7" off the floor. So that means that if you're like a 4 foot tall person, 4'10", there's a bunch of, shorter people, they can't reach it if you put the highest handle up at 7 feet. So there is a certain height that we have to stay within, and 6'7" to the highest handle is that height. You can go lower if you want, like this is probably 5'5", 5'4", something like that. This one's even lower, like it's down to my chin. That's okay. You can mount these lower, just don't go higher than that. But try to make everything that you do very neat and clean, and think about the next person that's going to have to come behind you, because at some point somebody's going to have a breaker that goes bad, and it might not be you that gets called out in 7 years. It's going to be some other electrical company. But when they come into work, let them be blown away by your work when they open this thing and they're like, oh my God, that was an outstanding electrician that came in and put all this stuff. What you don't want is to be the other electrician. So when somebody opens it, you're like, holy crap, that is the nastiest panel I've ever seen. This person had no clue what they're doing. That's not professional. That's Craigslist, and you don't want to do that. You want to do really, really clean, good professional work. So always try to make things easier on the next person that comes behind you. Try to do things in nice curves or straight lines, like think about every panel that you make, try to make the next one even better. That's just a general tip for keeping things really clean. I think I mentioned this before, but I like to put ground bus bars on the bottom. That's just my personal choice, because if you put the bus bars over here on the side, you got all these neutrals. You might have all these pigtails and all kinds of crazy stuff going on over here. So it makes it way harder to get in and do anything. And if you have to take a ground out later and move some stuff around, it is a pain in the butt. So this is make it easier on the next guy, or make it easier on yourself if you're coming back and doing it. And I think the bottom is completely unused space most of the time. So bottom is just what I choose. The next thing to think about is protecting the actual conductors. Everything that we do as electricians, we're always trying to protect the conductors. That means when we're pulling wire, we don't want any sharp abrasive stuff that we're pulling that against, because it'll actually strip off all this insulation and damage it. And then you're going to have a short inside of a pipe somewhere, inside of a conduit. I'm sorry, they're not pipe. Plumbers use pipe. We use conduit. But you want to always protect the conductors. So a lot of times, if you have any conductors that are 4 AWG or larger, we have to, per code, put some kind of protective bushing or fitting, something that guards against any kind of abrasion. The larger conductors that we have, if there's a short, the more available fault current that there is, so the more damage that can be done on a conductor like that. So that's why the smaller ones, they don't really care about. If you got like some 1/2 inch stuff in here, you can always put more protection. So if you want to do all your 1/2 inch and 3/4 and 1 inch stuff like that, more than welcome to. Code book is always a minimum. So at a minimum, if you have like a 2 inch and you got some 4 AWG or like some 4/0 conductors or something, put a bushing on that. And I always try to put whatever my connector is, I feed my conductors in, and before I let go, I slap that bushing on and put the lock ring on. Well, lock ring first. But a lot of people forget it, and then they'll come through and they'll bend everything and they'll cut it, get everything torqued, and they'll do this whole thing, spend 2 hours in here, and then they will close it up, and an inspector comes, and the first thing they look at is, oh, you forgot the bushing, fail. So you'll get a red tag. Another tip for those of you putting breakers in panels, only use the breakers that are approved for the panels. You might find another breaker from a different brand that fits into here that you can cram in. That doesn't mean it's listed. And if you get it wrong, if you put a breaker in here that kind of looks like it, but it ends up not fully seating and it causes a fire, it's on you. It's not on them, because you put the wrong stuff in here. Some of the brands from like a long time ago, 60s, 70s, stuff like that, there might be like old Murray panels and stuff like that that you'll be able to find direct replacements for, like Siemens panels or something. So a lot of these manufacturers have lists that they keep of certain breakers that they do test and they certify that they're okay to use in the panels, but you need to know that before you just go randomly stick one in. So maybe do some Google and put a list together of all the different brands that work together. Another thing, this is just a recommendation that I do to try to keep things really neat and pretty, is I try to put all of my ground fault breakers together, all my arc fault breakers together, all my dual function breakers together. I even try to keep like all my 2-pole breakers. These are all 2-pole breakers on the bottom. So I might put like all my single poles, stack them here, and then I'll leave some space and I'll knock out the rest of these on the bottom and put all of my 2 poles here. It just keeps it way easier when you walk up and you're trying to find something, like all the reds are over here and I'm looking for a GFCI breaker. So I just know like, boom, it's going to be one of these like 4 here at the top. Or if you're not, if you're looking for 2-pole breakers, you're like, oh, none of those are 2-pole, boom, they're all down here. It just makes it a lot easier. It's like putting your screws vertically on your receptacles. It's just one of those things that I think is smart to do. All right, so I hope you guys learned something. When you're doing your work out there, again, do everything neat, clean, pretty, level. Always challenge yourself to do better work than you did the day before. You don't have to impress anybody out in the world, and you're not gonna for a few years anyways. So just always try to impress yourself. And if you do something, try tomorrow to do it even better and keep growing, and be safe out there. I love you, crazy people. Thank you so much for watching, and I'll see you in the next one.